Here we go into a particle motion problem. We briefly discussed particles in the first video in this introduction into position, velocity, and acceleration. Now we're going to actually do a problem with it and see that it's no different than some of the other problems we've been doing. Then I invite you to stick around and check out the exercises. So this says particle motion problem. The position of a particle moving along the y-axis is given by this function, t squared plus 6t minus 16. Y of t is the position of the particle, so where we are on the y-axis, and t is the time measured in seconds, how much time has elapsed. So essentially, imagine that you've got some kind of vertical line that you're moving up and down on. We want to know where we are, how fast we're moving on it, and how fast that velocity is changing. What is the particle's velocity at t equals 3? Velocity, again, is the derivative of position. So we want y prime of 3. That's essentially what we're going after here. To find that, we've got to find y prime. So y prime of t is very simply the derivative. And the derivative of this is nice. That's going to be 2t plus 6. Nice. Then we're going to insert 3 into this function to figure out the velocity at 3. So y prime of 3 is equal to 2 times 3 plus 6. And 2 times 3 is 6 plus 6 is 12. We need those units. Do we have units is the question, though. We have seconds. But we don't have units going up and down the y-axis. So in this case, and in a lot of particle motion problems, there are no units. So we'll just leave it as 12. But it would be something like meters per second or feet per second. Then it asks what direction or in what direction is the particle moving at t equals 3. And so I'm going to give a little justification here, a reason. Since the velocity is 12, which is more than 0, it's greater than 0, positive, the particle's moving upwards. Remember, the velocity tells you in what direction you're moving as well as how fast you're moving. When we're positive, we're going in the positive. Y-axis, positive, is upward direction. So I'll say the particle, and I'll do it out formally here for those of you taking the A, B, or BC exams, is moving upwards. And we'll be real formal. My writing might not be formal, though. At t equals 3, since, and this is where you can abbreviate using math notation, y prime of 3 is equal to 12, which is greater than 0. You're stating that you know that the velocity is positive, right? But you've also got to use the number of what that velocity is. That's it. Let's keep going. What is the particle's average acceleration over t equals 0 and t equals 4? Average acceleration is v of, so the change in the velocity over the change in a time over an interval. You're finding the slope of the secant line on velocity, not the instantaneous rate of change or the slope of the tangent line. So that would be v of 4, the slope from 4 back to 0, v of 0. You might be like, v of 0, what is v? Well, we should probably define that here. Y prime of t equals v of t. That way we know what the heck we're talking about, right? Otherwise, where did this v come from? All over 4 minus 0. That would be the average acceleration. Well, to find v of 4, you're literally just plugging it into y prime. That's this. So y prime of 4, or v of 4, is equal to 2 times 4 plus 6, or 14, right? 8 plus 6 is 14. And then we're going to find v of 0, which is the same as y prime of 0. You plug 0 in, we get 6. So that's 14 minus 6, all over 4 minus 0. Wow, I didn't mean for the numbers to come out nicely, but they will. So 14 minus 6 is 8. All divided by 4 minus 0 is 4, and that would be 2. And we don't have units here, though if we did, and let's say position was in meters, it would be in meters per second squared, because we're dealing with meters per second over seconds. So no units in this particle problem. But 2 is the average acceleration, the average rate at which velocity is changing over that interval. Last but definitely not least, let's do this. Part C, find the acceleration of the particle when its velocity is 0. Okay, so we want essentially y double prime of t when y prime of t equals 0. That's what this problem translates to. So write out that blueprint and then follow your ingredients. So when is y prime of t 0? Here's y prime of t. So we've got 2t plus 6 is set equal to 0. So we solve that. That'd be minus 6 divided by 2. So 2t equals minus 6, divide by 2, and you get negative 3. Could you have negative 3 seconds? Sure, if it's 3 seconds ago, absolutely. So we want the acceleration 3 seconds from when we started. I know that's weird. But let's plug in the -3 into the acceleration. So it'd be y double prime of, well, -3. And that would be the acceleration at the time when the velocity is 0. So what's y double prime? We need to find it. So notice how we don't know what we need until we get to what we're asked for. Right, so we're being asked for y double prime. Let's find it. Y double prime is the derivative of y prime, which is 2t plus 6. The derivative of this is 2. And so no matter what, our acceleration is going to be 2. It's a nice constant acceleration. That's it. That's a particle motion problem. It's treated no differently than a falling object. You'll see in the exercises I'll go over another particle motion problem along with some other goodies that we haven't explored yet. I hope to see you in the exercises for this lesson. Peace.